Hello everyone, my name is Nawaf Abu Aqil and I am a math teacher at the Ahliya School for Girls in Amman, Jordan. Today I'm going to talk about some particular effect of frequency, which is called the stroboscopic effect. In order to understand this effect, this fan has 3 blades. I wrote a word on one of the blades, and as you can see, the blades are rotating so fast that nobody can read the word I wrote on one of the blades. Now, at the end of this module, you will be able to read that word. Now, I want you, in order to do so, to discuss with your teacher and with each other some effects of the frequency, the definition of the frequency, the definition of low and high frequency, and to give examples of some periodic phenomena and their frequency. I'll see you in a couple of minutes. Enjoy. Welcome back. I'm sure that you found some examples of high frequency and low frequency phenomena. One of the examples that you can give is a car wheel which is rotating slowly or very fast. When it's rotating very slowly, it's called a low frequency phenomenon. And when it's turning or rotating very fastly, we call it a high frequency phenomenon. Okay, let's now turn on this light bulb. Electricity in Jordan is about 230 volts and a frequency of about 50 hertz, which means that if this is an AC alternative voltage, the light should be going on and off. Now, if you look at it, I do not see it going on and off. Can you explain that? Now, let's take another example. Look at this LED, light emitting diode. It's a red light emitting diode. I'm going also to turn it on and observe what's going on. Your eye can catch when the light is on and when the light is off. Now, let me just increase the frequency. Just gradually. What's going on? What do you observe? Now, let me increase it again. Let me increase it further. Look what's going on. Look at that. Now, let's increase the frequency further. Here you go. What do you see? The LED is not blinking no more. Can you explain that? When I was at low frequency, my eye could catch the on and the off of the light. Now, it cannot. Can you explain that? Now, in order to help you, let me just explain to you what an AC is. An AC voltage is something like this. The AC voltage is on the vertical axis. Let's call it V, and it's measured in volts. On the horizontal axis, we have the time, and let's say the time in seconds. Now, an AC voltage is a signal, which is a sine signal, like this. It goes up, and then down, and then it goes up again. Now, this is very approximate, I know. We have very particular points on this graph. This point, let's call it 0, and this point, point A. Then we have point B, which is at 0 voltage. And then we have point C, which is another maximum voltage, but on the negative side. And then we have another 0 voltage over here. As you can see, this signal will continue on okay? So this form will repeat forever, okay, as the light is on. Now, I hope that this will help you to discuss with your teacher and with each other why the light was on and off for the LED, okay, and I could see it, but not for the light bulb. I'll see you in a couple of minutes. Enjoy it. Let's make a toy together. It's a very simple toy. You just take a small cardboard like this one, okay? And then you just fold it in two, like this. Just fold it. And then you draw whatever you want. Let's say I'm gonna draw a cage over here on this side and a bird on the other side. Or a ball, football or whatever it is, and a football player on the other side about to kick a ball. Then use some adhesive tape to tape it, to keep it folded, and then just insert a toothpick or a stick over here in order to be able to rotate the toy. And it comes finally like this. Okay, the cardboard, adhesive tape, the toothpick, the cage, and then the bird on the other side. Now try to rotate this toy, put it like this, and try to rotate it. What do you observe? Try to rotate it like this. Okay. Okay, now I'll leave you for a couple of minutes to discuss what do you see, okay? And then we'll discuss what is going on. Enjoy it. Welcome back. If you tried the cage and the bird, you must have noticed that when I rotate this toy between my fingers like this, I see the bird in the cage. Did you notice that? Good. Let's now try another toy. Here's blank disc. As you can see, you have like frames over here, and you can draw whatever you want, an object, let's say, that is in different consecutive positions. It's like a horse, let's say, or it could be a car or whatever. Now, this disc is like this one. Here's the disc. We'll take the example of a running horse. The horse is in different positions, as you can see, and these are still positions. The horse is not moving, right? Okay, now let's see this toy. So the lower part of the toy is just a rotating disc, okay, and the upper part of the toy, it's like plain mirrors, okay, arranged in this form. Now, if you put it over here, okay, here you go. And now, if you rotate the disc, these mirrors, okay, will constitute the frames. And if I rotate the disc, I will see the horse running. Look at this. Can you see that? Let's try it again. Again. All right. I think you understand the thing over here and the concept behind this. Now, why do I see the horse running while I have only still images? It's simply a question of frequency. When the frequency of some rotating phenomenon or periodic phenomenon exceeds some critical value of the frequency that the eye cannot catch, for the eye, this motion will seem as fluid and continuous. And this is exactly the principle of movie making films. Now, on the inverse, I can also freeze the motion of a fast rotating object. How do I do that? I use a device which is called a stroboscope. we can actually use a device called a stroboscope. It is a flashing device that gives flashes per second. I can adjust the number of flashes, which means the frequency, as I want. I can increase it or decrease it. Now, if I have a fast-moving phenomenon or rotating phenomenon, I can freeze the motion of that phenomenon if I can find the right frequency on the stroboscope. That means if I match the frequency of the rotating phenomenon, I can freeze the motion. Now, that means that frequencies or certain frequencies can induce illusions for the eye. Can that be dangerous in some situations? I want you for the next couple of minutes to think about some phenomenon and to see if the frequency of that phenomenon is dangerous or not, or could it be dangerous or not. Think of some rotating objects, okay? You have so many around you. I'll see you in a couple of minutes. Welcome back. I think that you have come up with some examples. It's like a vertical saw or a drill or any other example actually. But now let's get back to our problem. We have here the fan, and I told you that I wrote a word on one of the blades, and we can still not read that word. Now using this stroboscope, we will be able to read that word. Watch with me. The stroboscope is on, and now I'm going to increase the frequency of the stroboscope until I can freeze the blades. Here. Do you see it? Can you read the word? Good. Excellent. Okay. So now that we finished with this, I'm going to tell you why this phenomenon can be dangerous. Now, let's imagine that you are in a carpenter shop and there is a vertical saw, and the vertical saw is rotating at the same frequency as the light of the shop. Now, if the light of the shop is matching the frequency of rotation of the vertical saw, the saw will appear still, exactly like this blade, and you might harm yourself if you get close to that saw. Thank you. That's it for today, and hopefully I'll see you another day and next time. Thank you. Hello fellows, I hope that you will enjoy this module today. This module is about frequency and the stroboscopic effect. The main point of this module is to show that resonant light frequencies might cause dangers in some situations. So during the first break, please try with your students to define the terms frequency, low frequency, high frequency, and take some examples of phenomena that is rotating, let's say, or periodic. During the second break, we used a light bulb and a LED, light emitting diode, and we used different frequencies for the LED, so we control the frequency. And for the light bulb, we just used the main frequency, which is about 50 Hertz. Now, you can make use of this graph over here, which is an AC voltage, as you can see, and it's actually in segment 2 also, if you can see it before, and explain to the students that at points A, B, and C, which are the intercepts with the x-axis, which is the time axis, the voltage drops to 0, which means that there is no light. You can also connect the frequency to the period of the signal to explain why at low frequency we can see things blinking, going on and off, and why at high frequency, when the period is very small, we cannot see them, so we see them always on. In segment 3, the students know by now that beyond a certain frequency, the eye cannot catch images. The toy that the students can easily make, and it's explained in details in segment 3, so I'm not going to re-explain it again. I'm talking about the toy with the cage and the bird. When you turn it actually at a high speed of rotation, you can see that the bird is in the cage. You have to explain to the students the persistence of the eye, which means that when the image comes to the eye retains the image for a fraction of a second. Now, before that image can leave, another image will come on it actually, so the eye will see a fluid continuous motion, and that's exactly the principle of movie making in films. For segment 4, if you do not have the mentioned toy, I mean the running horse, and it's also explained in details in segment 4, you can still, with your students, invent another toy for the same purpose, and it's exactly the same thing. The toy is this: you just take a notebook like this, a small one or a big one or a large one, it's okay. Now, inside, you have just to draw some object, like a heart over here, and then the heart in another position, like it's flying, and so on. And then you might get to draw a cat, which is trying to catch that heart in different position also. Now, if you flip this notebook like this, you should see the cat running after the heart. And it is the principle of movie making. Now, even if you do not have a stroboscope, students can see how it's used by watching the module. Your role is to explain to them that when the frequency of the stroboscope matches the frequency of the rotating phenomenon, then the image will be still. It's like you are freezing the rotating object. Now, explain to them also that you have many frequencies where you can freeze, let's say, the blades of the fan, but the frequency of rotation of the blades is the frequency matching the highest frequency of light coming of the stroboscope that freezes the blades. Now, if you do not have a stroboscope, you can still make one with your students. This part is called the extension of the module. This part can be done separately and later on when students have time. Make your own stroboscope. You can make your own stroboscope using a plastic or metallic disc. Make equally spaced 10 or 12 sectors, as you can see on the image. Use a small DC motor to rotate or rotate it manually. In a dark room, use a light box to shine your desk and rotate it. You have then a handmade stroboscope. Try to find out the speed of rotation of the blades of a fan using your stroboscope. And I'm telling you that you need some basic mathematics to do that. Thank you very much. I hope that you will enjoy this module. Bye-bye. Welcome back. I'm sure that you found some examples of high frequency and low frequency phenomena. One of the examples that you can give is a car wheel which is rotating slowly or very fast. When it's rotating very slowly, it's called a low frequency phenomenon. And when it's turning or rotating very fastly, we call it a high frequency phenomenon. Okay, let's now turn on this light bulb. Electricity in Jordan is about 230 volts and of frequency of about 50 hertz, which means that if this is an AC alternative voltage, the light should be going on and off. Now, if you look at it, I do not see it going on and off. Can you explain that? Now, let's take another example. Look at this LED light emitting diode. It's a red light emitting diode. I'm going At the end of this module, you will be able to read that word. Now, I want you, in order to do so, to discuss with your teacher and with each other some effects of the frequency, the definition of the frequency, the definition of low and high frequency, and to give examples of some periodic phenomena and their frequency. I'll see you in a couple of minutes. Enjoy. Hello everyone, my name is Nawaf Abu Aqil and I'm a math teacher at the Ahliya School for Girls in Amman, Jordan. Today I'm going to talk about some particular effect of frequency, which is called the stroboscopic effect. In order to understand this effect, this fan has 3 blades. I wrote a word on one of the blades, and as you can see, the blades are rotating so fast that nobody can read the word I wrote on one of the blades.